right, let's get this panel started. So this panel is about modularity, and specifically we have two projects coming from the DA space. But before diving into it, let's get a round of intro.
Hey everyone, I'm Matt. I'm ETHDenver. ETHDenver is a hyperscalable DA layer for Ethereum L2s.
Hi everyone, I'm QEDK. I work as an explorations engineer on the Avail team. And at Avail, we want to be the Web3 unification layer.
Okay, and what is one happiest moment in ETHDenver for you, each of you?
Biking in between events on the bike, music on, sunny out. Those have been peak.
Okay.
I think for me, I love the Denver scenery. Downtown is sketchy for sure, but if you head up to Red Rocks, it's quite sweet up there. The air is thin, but you enjoy the hike.
Lovely. Okay, so let's dive into the questions. Let's start from that very high level. Let's not assume everyone here understands the state of the art or the trendy narratives. Can both of you explain for us what does it mean by scaling blockchain in a modular approach, and how does that differ from scaling a monolithic system?
Yeah, for sure. So typically, we have to kind of break down rollups into several components, right? Today, when we talk about monolithic chains like Ethereum, what that typically means is they're secured by themselves, right? And when we go on to L2s and L3s, what that translates down to is that now rollup operators, rollup developers have a choice as to what components they want to build with. Typically, that's going to be data availability. So you can have alt DA like Avail, Celestia, EigenDA. You can have different settlement choices. You can settle on your own chain. You can become a sovereign rollup, and you can choose your VM, which is typically the execution. So you can be as generalized as you want, like EVM, or you can kind of pick like a very small VM language that you kind of make yourself, which is customized for a particular purpose. Yeah, that's what I think.
Yeah, and to expand on that as well, a personal mental model for modularity as a whole is like specialization. Essentially, you're breaking down a larger system into its individual components, and at each of those levels you can then like optimize, sort of pick and choose, create like customized full stack. So there's across Web 2 and Web 3 you have a lot of representation of like both vertical scaling, which is like, hey, do it with bigger, better computers, or this idea of like horizontal scaling, which is adding additional layers essentially of compute. And that's similar to the model that you have when you talk about rollups on top of Ethereum, is this idea of sort of horizontally scaling as well as individually. Then you can combine vertical scaling within.
Yeah, there's this inherent tension, right? In order to scale a global consensus system, if you want more performance, you in one way or another, you arrive at bigger blocks, and that requires fatter nodes, and that requires a pressure towards the centralization direction. Okay, so coming to DA, so both of you work in the DA area. Can we try to use first principles in simple terms? What is the data availability problem?
So when we talk about the data availability problem, what that boils down to is that, let's say that there is a particular rollup, and that has some particular transaction data. How do we verify that some particular transaction or data is actually there, right? For us at Avail, we believe like a solution which is trust minimized is something that works, right? So what we are saying is that if you run an Avail LC today for your particular rollup, your LC can just verify using KZG validity proofs that the data is actually there. To a reasonable amount of guarantee. And the guarantee is something that you can pick, right? So you can have 90% confidence, you can have 95% confidence. But what that boils down to today, we effectively have a state-of-the-art LC validity proof architecture that no one else in the ecosystem has. So let's say that you are a ZK Sync Elastic chain, and you have a particular rollup that is interoperating with these chains. If you have an LC, your DA guarantees are automatically provided by the LC, because the validity proven architecture ensures that all the data that the rollup is saying it's there is actually there, and that it is correct. And it is incredibly foolproof because it is a validity proof. And that's a crucial distinction that I believe we have in the DA space, where if it's self-secured, you have to kind of ensure they have cryptoeconomic guarantees, right? So typically that's going to be like, which is why all L1s are DA layers, because they are self-secured, which means you need to have your DA on yourself. And this is kind of the choice that rollup devs can make, that if they pick an alt DA which does have a feature where the LC can kind of do this verification in itself. They don't need another feature. They don't need X other things. It just works for them.
Yeah, and clarifying for everyone else as well, if we're talking from first principles, LC refers to like client. DA layer itself, yeah, I guess the idea or like also reason why it is relevant is that if you have a system where multiple participants are interacting with it and essentially deciding to update and requesting updates to stake, how do you enable that anyone can check and actually ensure that the state updates were made correct? And when you're working on an L1 where it has complete view across the stack, when we were breaking down before the parts essentially of a blockchain, when you separate out sort of execution and consensus, which essentially is what rollups do, you have execution, a state transition function that is outside of the purview of the L1 itself. So they're going ahead essentially creating additional chains, and there's many of these, and they're creating additional transactions, and you need to be able to put these transactions somewhere such that anyone can verify and ensure that the state of the network is correct. If you don't have that, you're essentially working under Web 2 assumptions that you did it right. And yeah, as far as some of the bottlenecks that we think for this as well in crypto, and you hear the conversations around Ethereum itself being slow, it's yes, there are things that are optimized on the L1 itself. And for decentralization and censorship resistant, Ethereum is leading that. And what we're able to do with this roll-up centric thesis of scaling through roll-ups, also scaling the L1 importantly, these roll-ups are continue to post data in a shared sort of manner. And you've introduced blobs as maybe one way where you can post them directly to Ethereum, the same place that you're posting for settlement as well, and have high security guarantees as well. But we're also seeing that there is limited capacity to be able to scale the amount of data that you can post to Ethereum itself or other L1s. And how we view it at EigenDA as well is that for all of these chains to be able to scale, scalability is the bottleneck, and we do not want that to be the case for Ethereum L2s. So we focus on scaling Ethereum L2s in particular, where we are built on top of Ethereum to be able to scale essentially, and our model is essentially roughly follows to being data sharded. Essentially, data is erasure encoded and split amongst the network essentially, and can be reconstructed at a later time as well. And you can have high guarantees of that, and we're working to give further guarantees with things like clients as well. So. That's maybe a little bit of context, I guess, on DA. And
yeah, I think one more high-level question, but I think these are quite important because they're quite universal. Okay, so the question is: it seems that the benefits of DA layer design can be quite difficult to grasp by end users of the rollups. So it means that you are, as DA layer project, you're pitching to rollups. How do you understand that your DA project is contributing to the users of the rollups, or do you think that so what makes these different DA layers different, and how does that translate to making these rollups more competitive, easier to use, more interesting? Because I think that's ultimately how these rollups are making decisions when they come to choose these different DA solutions, right?
yeah, definitely. I would say that I hope as an end user you don't have to care. The way that you might care is typically in your pockets as far as what are your transaction fees looking like. And there's probably a breakdown that I would consider for DAs that you might consider one of the reasons why people, teams, right? So these are teams, businesses that are building that have to be considerable of the economics essentially of their chain so that they can support users, applications that want to build on them compared to however many options they might have. So I would kind of break it down, cost is something that we would definitely consider. Transaction fees, people can harp on that on L1. Well, we're focusing on particularly scaling on the L2 layer, the cost fees where you get down to more predictable cost economics. One thing that we can actually offer with EigenDA is this idea of reserve bandwidth. You can actually you have predictable economics. For a user, what that might actually look like is that you can have a higher assurance that that sort of DA value is locked in, so your transaction cost isn't going to randomly spike when there's the most desirable time to interact with the blockchain then becomes the worst time. So like cost, capacity, and customization are kind of some of the things that come to mind as far as for an end user. The DA layer itself should be highly scalable, right? You don't want that to be the bottleneck. And for an end user, it should just work kind of and largely be abstracted. I think that these are decisions that these teams, blockchains instead are making themselves, and should be really mindful of the type of product that they want to build on top of them.
Yeah, I think cost is definitely a factor, but I think the primary reasoning that you should kind of pick a DA is because of the DA guarantees, right? The data availability guarantees. If you're a rollup that is sort of posting your data to Ethereum, you know that the Ethereum validators are securing that data with their consensus algorithm, right? The same thing applies to typical DLRs like Avail or Celestia, where there is a consensus, where there is cryptoeconomic stake that is ensuring that KZG commitments are correct, that is verifying those KZG commitments, and that is ordering the transactions. And this is when we come to another element of why rollups use a DA, which is that your DA layer is effectively where you're ordering transactions, right? Because rollups typically don't have consensus, what that means is that whatever data that you submit to a particular DA, whether it be Avail, Celeste, or EigenDA, that is effectively your canonical view of the chain. That is where ordering gets done, right? And this also plays into interop, right? Let's say that today we have Avail Nexus, we also have Avail DA, and then we have multiple chains that are kind of interoping through this Nexus solution. What this means is that the ordering that is done on Avail is going to be the ordering that determines how that interop takes place. And without these ordering guarantees, a lot of the guarantees that we could get from DA for a particular rollup, they go out of the window. Right? And this is not me saying that you cannot provide those guarantees in other methods. This is just me saying that applying cryptoeconomic stake is effectively different than any other approach. Like, for example, you have some stuff like OPDA, which is effectively nothing but posting data to like an AWS S3. And I'm not saying don't do that. I guess I am saying don't do that. But also, there are effectively no DA guarantees that you can derive for your rollup by posting data to a centralized service. And while that's a choice that users won't care about if they don't know, for rollup operators, what that means is, let's say today you're an optimistic rollup and tomorrow you want to exit. As soon as the data is unavailable, you just can't exit the network. That's effectively what it boils down to. And then similarly in ZK, but it's functionally different because you can always prove that there is a soundness bug. But then again, without the data, you don't really know what to do with your chain, right? So that's where I think we sort of differ, but also I think cost is a big factor as well. Particularly, I think the comparison with Ethereum is something that we also talk about as well, where on average, I think almost all DS today are probably magnitudes cheaper than having Ethereum on DA. So yeah, that's what I think.
And yeah, I would add on the interop side of things as well. I think that is like one thing that EigenDA is not necessarily focused on. Like, we're focused on purely DA. It's like pure DA in that sense, and then we don't have ordering on that instead because we're targeted for Ethereum L2s, and there are interoperability solutions that are built for bridging or building state essentially between these rollups themselves as well. So I think that is like there's different factors, and I guess to the question, I was largely focused from an end user standpoint. I think that scalable applications, one with high guarantees of censorship resistance, will be like revealed as far as probably in the long run of where people will go because they can't be like rugged. But also in the immediate term, I think that predictable costs are nice for teams to be able to stay around and sustain themselves.
Yeah, I definitely agree. I think, again, like EigenDA definitely works for people that use EigenDA. I completely believe that. And primarily, I think we are saying the same thing, right, where rollup operators should get the choice to pick the security guarantees that they want. What that kind of also boils down to is that developers should be effectively educated on what DA guarantees are. And if it is something that is of less relevance or something that they want to kind of solve in a different manner, then they should be free to do so. And that's sort of the power of modularity, so to say, where you can actually take parts of the stack and you can opt in and opt out. Because otherwise, what's sort of the point of building walled gardens in crypto? That's what I think.
I have a bunch of interesting questions that I really want to ask, but there's time constraint. But I guess a remark that I wanted to make is that at the genesis of the layer 2 centric sort of explosion, the idea is that let's not keep all the innovation within the imagination of a single blockchain. Let's sort of roughly fixate what the layer 1 blockchain does, upload the interface, and then always in my mind, I imagine you go to a forest where there's known to be truffles. You basically bring like this big basket of little piggies and just go find truffles for me. And they're going different directions. They start having different theses, and hopefully you find truffles at the end. And that basically means that this entire layer 2 modular ecosystem is in one big experimentation. Every project has its own thesis where the power dynamics eventually will evolve into, and where sort of the most usefulness and value add you can provide and there's, I guess, for my thinking is Avail's approach is a little bit more vertical in the sense that you want to solve interoperability also within your picture. Just go all the way because interoperability is a known problem that is felt by the users. And from the Eigen perspective, you're at the moment ruling that out within your scope of the project. So, but I think it's very interesting that we're in this one big experimentation, and market will tell eventually what kind of architecture, particular modular architecture, makes sense. But I think let's give some moment to each of you to talk about what is unique in your solution. So let's start with AVS. What is an AVS? What does it unlock for the industry? And for you personally, what are some interesting AVSs?
Sure. Yeah, I guess like more broadly, AVS stand for Autonomous Verifiable Service. The idea of that naming is that these are, if you have a decentralized, like sort of permissionless system, these are running on their own, can be verified and checked by anyone. And I guess to your point, as far as this forest, wanted to touch on that as well. I think it's awesome to see is that what we're seeing evolve is many horses in the race, and decentralization, particularly bundled with that permissionless decentralization, creates really good markets. And like markets are great and highly, hopefully, efficient over time, where you're going to see users and teams, find and continue down these paths where it should lead, at the end of the day, hopefully, to solutions that people want and can use. So an AVS itself is a combination of on-chain and off-chain components, smart contracts deployed on Ethereum, and off-chain, you can think of it as like compute, and it can be a wide varying architecture. Anything from a smart contract emits an event on-chain and something picks it off that's too computationally expensive to do it on-chain, to something like EigenDA that is built, like purpose-built in that sense of it allows us to have a permissionless operator set of like 200 operators operating the network. For us, that's like very important that we continue to be able to scale that amount. And what we focused on as well is scalability, as well as further building out our decentralization. And that architecture essentially looks like that's, the data is erasure coded, KZG commitments made, chunked, and you've got a multi-reveal proof sent to operators. They do a pretty basic thing. They're essentially like having the guarantee of like validating, storing, and serving the data when requested. Anyone in the network can request and reconstruct that data at any time. So our focus is ensuring that we have like high scale, like decentralized data availability, and look to continue to push packs like 15 MB that we are at today, and hopefully allow for L2s to really like lead the way as far as high performance and on top of Ethereum.
Awesome. So coming to the Avail side, you have a pretty extensive stack. Can you walk us through the different layers from light client all the way to Fusion, and how do these components fit into the same picture?
Yeah, for sure. I think the crucial aspect is that, as I first said, like every base layer is a DA layer, right? So you're secure by itself, which means that Avail naturally is also an L1, which means we have our own cryptoeconomic consensus, which means that we have your DA that is kind of posted on Avail is eventually secured by a high amount of cryptoeconomic stake. And so let's say that you are a roll-up or you are an end user. It means that your transaction data ends up on the DA layer. And the reason that we can provide those additional DA guarantees is something that we have, is the validity proof feature that we have in the Lite clients, which is effectively saying, similar to how they also have KGG commitments, we have Reed Solomon encoding where they get erasure coded, and then we make a KGG commitment. I don't know if you have the same SRS. I don't know if they're compatible, but effectively the logic is the same, where effectively if you are a rollup that is using the LC, those guarantees are built in, right? And then when we say your rollup has an LC, typically there are two ways to think about it. One is that you can actually embed a Lite client inside your rollup sequencer. That is one. So you can derive guarantees from there. And the second is each of your rollup users can run a Lite client, and you can have a setup where your entire chain is user verified. That is sort of something that we haven't really seen yet. But I think as we kind of go towards more specific and more special use cases, we're going to see teams actively choose to kind of choose the sovereign rollup route, because when you don't have to worry about settling to a particular layer and you can just build an enshrined layer to that enshrined bridge to that layer instead, what that means is that you can actually customize your chain to do much more, many things that typically you cannot do in the generalized VM structures that we have today. Right, and I think with solutions like Carnot, RAS, and even like newer RAS providers that are sort of not doing just another OP stack solution, I think with them we'll actually see like sovereign rollups being deployed. I think Sovereign Labs is doing good work there. They have been actively working on a sovereign stack for a long time. So yeah, for sure, I think we're going to see more and more solutions that are actively kind of tackling the problem in different ways. Because while L2s and L3s are great, while having many L2s and L3s are great, what that kind of means is that everyone's kind of solving the same thing, and we're all competing for the same pie. Right? Ideally, we should be kind of figuring out how to sort of vampire Web 2 instead, right? Like how can we onboard Visa, which we are actively trying to do, we as in crypto, of course. But what kind of that boils down to, can crypto really handle Visa scale today? The answer is probably no. And I mean, you could consider cases like Sui and Aptos, but even those chains, like they have certain mechanisms which ensure that they don't function at their optimal capacity, right? Like you can DOS the chains quite easily, which means that you sort of have to work around consensus algorithms and submitting transactions and so on and so forth. What that boils down to is that we aren't there yet. But as we sort of get more innovative, we're going to see more roll-up operators actually kind of go the more customized route, because like once your distribution is gone, right, then you kind of have to focus on the tech. And that's what we're seeing, where there's a lot of distribution today. We have big chains with big TVL, but it's like just sort of a retail product that people can just use for everything. So then it's like, does distribution win? I think for now, sure. But eventually there'll be a version of events where the tech wins and then they'll get distribution as well. So when we talk about the roll-up thesis, this will kind of expand on the last point, which is like, how does our stack look? We're also working on something called Nexus and something called Fusion. And our Nexus is essentially a suite of interoperability apps. So we have essentially validity proven slow paths, optimistic fast paths secured by cryptoeconomic stake, and we have something called TE Nexus, which is nothing but just a TDX based system that sequencers can use to kind of interop between themselves, right? So what we think is that what's important is to provide rollup operators a choice. Hence, what we want is a vertical stack that they can pick and choose from, and they can pick their right security guarantees, right? Because if you're a small chain, if you only have long tail assets, do you really need to have fast interop to base? Probably not. Would it be great to have it? Sure, but you don't need it, right? So that's kind of the perspective where we're coming from. And lastly, of course, we have Fusion, which is sort of essentially for now what it is going to be, you can stake Bitcoin, you can stake ETH, and that serves as cryptoeconomic system in the Avail ecosystem. And in the future, what this is going to be is sort of a shared security scheme where rollups can actually borrow the security of Avail and they can secure their own chains. And that's sort of an overview of the stack. That's kind of what I think.
I guess I didn't fully answer maybe your question as well. You're asking about the AVS side as well. It's generalized infrastructure, so there are teams that are working across the stack. It's a marketplace, right? So it's a market structure for anyone to be able to build, and brings together both economic security, those that can actually run these services, and the developers, and really like end consumers. And for the end consumer, for EigenDA, it's roll-ups, or by proxy, a user that's using a transaction on top. So personally, I really like ZK-TLS. I think like the design space of being able to, you mentioned a vampire attack. It's like kind of primed for that with essentially being able to prove arbitrary like Web 2 data, and also in a privacy preserving way is great. To services that can be like roll-up specific services, right? So you've had shared sequencing, or whether or not people discuss that exact term today, or decentralized sequencing as well. Other interop solutions, whether they're like something like a hyperlane that's kind of application level, like interop themselves. I think that across the stack, essentially, it's like enabling developers a better toolkit and like a marketplace to be able to choose and pick and choose something either they build themselves as a part of their own stack, or what exists out of the box. And I also would say that customization, there's a wide range of customization. We're probably in like the third inning as far as maybe where like the roll-up scaling ecosystem goes, and I think that a lot of those are going to continue to be ETHL2s as well. I'm curious to see how like the sovereign roll-up thesis plays out as well. So yeah.
Lovely. So last question for each of you. What is one interesting development on the horizon for your project, and what is one challenge that you're currently tackling?
Sure. I mean, I mentioned Nexus briefly in my previous answer, so maybe I'll expand on it a little bit. Effectively, as I introduced Avail in the very beginning, we kind of aim to be the unification layer for Web3. So what that means is we want to provide a stack of solutions that roll-up providers can choose from, and that actively works with them, like depending on kind of the security guarantees that you choose, to enable that particular communication at scale. So just to kind of expand on Nexus again, it's a permissionless interoperability protocol for rollups that allows them to communicate at scale with each other. Right? That's sort of what it boils down to. And then, as I said, we have several elements to it. I will not delve into it too much, but just to kind of expand, again, we have ZK, OP, and T Nexus, right? And I guess we are most excited about the ZK and OP Nexuses, because what that means is, let's say today you're an order on a cross, you want to make an order on a cross and your particular user. What's really securing your order, right? And effectively, probably that's going to be a human oracle. That's going to be something like UMA. That is going to be, if there's a dispute, that's going to be like, well, this order took or didn't take place. And then depending on that, you're going to get a certain payout, right? What we're saying is that why not make it automatic? Why not use state root-based guarantees? Why not use storage proofs? And why not apply a cryptoeconomic stake to solvers? So in the case that there are malicious solvers, in the case where they collude with roll-up operators, for example, such that rollbacks occur and the users don't get their funds, they can actually be slashed and they can be held accountable, right? That's sort of a brief overview of OP Nexus. But at the same time, also what I kind of want to stress is, although we have these guarantees, we want the user to be able to pick these guarantees, right? So we're actually designing a very extensible system on top of ERC 7683. And what that means is, you can actually pick a resolver. So you don't really have to opt into this. If you want, for example, to use human oracles like UMA, then you can for sure do that, and we don't really mind. If you want to use AVSs like Symbiotic or Eigenlayer, you can do that, we don't really mind. And that's sort of the open garden that we want to build, where we want people to just participate, and we don't want them to feel locked in. We just want them to have the best experience, because that's why they're here, right? They shouldn't be here because they're locked in. And we're seeing a lot of EVM stacks not choose to do this, which is not great, right? Because at the end of the day, like, that just means you have a walled garden that people can't really get out of. And what that means is, eventually, if there is better tech, they will have a very hard migration out of our system, right? And as we know, like, as I said in my previous answer as well, distribution has been working for now, and it'll probably keep working in long time in the future as well. But eventually, there will be tech that is good enough that people can't really just shove it off.
I guess the analogy there is, instead of keeping the door shut once they're in, you keep the door open. Let them have one foot in the door, and the thesis is they might stay longer that way.
Yeah, 100%. And what I can say confidently is that we feel they won't go out of the door. So that's why I believe we have.
Yeah, from the EigenDA and I guess broader EigenLayer side, EigenDA, we've been working on some updates that we'll be sharing a little bit more about soon, just on like really thinking how we can have like a sort of sustained and like continued like scaled system. We have like high aspirations for scalability at like 1 gigabyte per second, and like some time frame seems pretty aspirational, but more realistically for the end of the year we want to hit like 100 megabytes per second. So some things that are working towards that in the very near term we can publicly say soon. On the EigenLayer itself, I think continuing to see the like AVS ecosystem sort of merge this like concept of like the broader economy continue to push forward. And I'm excited personally to be able to see like AVS's and just like services as a whole being used by end user applications like that. I think is the reason why you have infrastructure, is that it can continue to bring up the floor of what you can do, and it should then raise like the ceiling of what these applications enable. On the challenges, I think that or like upcoming work that we're thinking about, I think like our DAS design as well is like a really like an open thing that we've been like researching for a bit. Not just like you can implement a DAS design itself, but we're trying to ensure in our design where we don't have a blockchain with consensus and are focused on scale, how do you enable that the DAS design gives you the guarantees that you want out of DAS itself, as well as it's not a bottleneck and it becomes like too bulky as well. So we have some open research, and then over the coming quarter as well, excited for some more actual like generation of as we actually will be rolling that out this year. So yeah, excited for the future.
Wonderful. That's it for this panel. A round of applause for the panelists. Okay, so it seems like the closing remark is on my shoulders. I don't have much what to say other than the fact that we're all working together to scale the blockchain, and it's a little bit like a dog forest ahead of us. How eventually sort of the end game of blockchain will look like. I think one danger of imagining the end game of blockchain is that if the application side is still evolving and killer applications are evolving, that actually percolate back and changes the architecture of the underlying blockchain. And so if you fix it into a particular architecture, you may losing out for new applications that are coming up. But I think that we're all exploring this in good faith, and the industry has made a lot of progress since a number of years ago, where all blockchains are basically all monolithic. So it's wonderful, and thank you for coming to the event today. Hope this is the happy ending for ETHDenver for you this year. Thank you.